Good morning, everyone. So this is going to be a short video. I wanted to just cover some basics about how you go about measuring different objects and the different types of tools that you can use. So we're going to just focus on that. Again, this is going to be a pretty short video, and that this is something that you would practice in the lab if you're going to lab. And in fact, we all cook in the kitchen. You're going to cook if you haven't started already cooking, and you're going to use measuring cups and other tools to help with figuring out the quantities. And so that's what we're going to do right now. Is we're going to sort of just focus on different ways of making measurements and how to make those measurements in a lab type setting. So now keep in mind that you are sitting in a seat right now, you're in a lecture or whatever the case is, and you don't have these tools, but we're just going to pretend, and we're going to just learn the different ways of how you can measure. So on the screen here, I've got two different tools that we're going to possibly be able to use. So the most common tool is a ruler. It's something that we just take for granted. It's something that we've used our entire lives. Now the difference is that we are in a chemistry course, and in chemistry we don't typically measure in inches as that you normally would do. We measure in centimeters. In fact, the ruler that you're seeing here right now is a ruler that measures to 30 centimeters left to right here. And now the way you measure anything, you have to line up the zero, which is here, all right, and that zero is your starting point. So an example would be, so let's say we have this line here. It's a terrible line, but either way, it's a line, and we want to measure it from the beginning to the end here. And so the way we'd go about doing that is, okay, we see that that the line is roughly, so going about right in here. So we know it's 20 at least. Now the question is, how far does it go? We know it's not 21 because 21's higher. It's not as long as 21 is, but we know it's 20. And keep in mind that these are centimeters here, of course. And so as we look closer here, I'm going to zoom in here. If we were to bring this down, we've got 1, 2, 3, 4, 5. So it's going to be in between. Let's see here. So we're going to come straight down to right here, right, roughly. That's 20.10 centimeters. Now the 1 I can measure. All right, so this 1, 2, 3, 4, and then 5. I can measure the 1, but the 0 is an estimated digit, and I can see that this right here, in fact, if I bring it straight down, is actually a little bit more than that 0.0. It's going to be like maybe 0.15 centimeters. So these numbers that you see here, these are measured numbers. These are actually numbers that you can physically see and read from your eyes. The 5, now you can see this and read it from your eyes, but the 5 is also called an estimated digit. And estimated digits are always going to be slightly different depending on the reader that is looking at the object. So you for yourself might find that to be something different and not exactly 0.15. You might say 0.10. You might say 0.14. Again, the estimated digit is important because what it does is it helps to secure the accuracy. It helps to explain how many decimal places this can measure to. You always want to read in between the lines, and that's true for anything. Now, the one thing that's the easiest would be this top loader balance. So let's say that I put some type of object on here, and that object measures to be 2.013 grams, and that's what you see on the screen. So we would write down 2.013 grams. Mass is the easiest thing to measure, and all three of these are the different types of balances. This is a top loader balance. This is an analytical, but it also is called a top loader balance. And then this is a much more precise instrument. This is an analytical balance. And so you might use those in the lab as some of you guys move on into 1251 later. So for now, what I want you to be able to do is understand how to make measurements. In this case, if it's on the balance, you just write down the value that it gives you on the screen. If it's in the ruler, you're going to have to measure that ruler, but keep in mind that when you measure, you record it with centimeters, because that's the unit that's preferred, and you measure it to the point where you can estimate in between the line. And that takes a little bit of practice, but again, it's something that you need to make sure you are comfortable doing. Now, something else that we use, and I do not have a picture on the screen here of this, is a graduated cylinder. I couldn't find a good picture online. So this is a graduated cylinder. I'm going to abbreviate this here. And a graduated cylinder is used to measure volume. All right, so the ruler is measuring length, the balance is measuring mass, and the graduated cylinder is measuring volume. Now, volume typically is measured in units of milliliters, all right, and every graduated cylinder that you see will have a certain value to it. And so let me take you guys to Google right fast. I'm going to look at a couple pictures. So these are what graduated cylinders actually look like. And they're specific for measuring volume. All right, so this is a good example here. So this graduated cylinder measures up to probably 100. I obviously can't tell it's 100, but I can pretty much assure you this is a 100 milliliter graduated cylinder. There are other. So this is one that's most commonly used in the lab. It measures from 0 up to 10. Now, the next thing that's important about this is how we go about measuring. So if you look at this picture here, you can see it's not a straight line across. You can tell that just because of the actual line itself here. And if you notice that this goes between 20 and 30 milliliters, so this goes up by 1, 2, 3, 4, 5, 6, 7, 8, 9. So this goes up by 1 milliliter increments. So when you make a measurement with a graduated cylinder, what you typically do is the curve that's inside is called a meniscus, and you measure at the bottom of the meniscus. All right. So again, the meniscus is going to be found inside, and it's going to be a slight curve. The smaller graduated cylinders, you can easily see this curve, but larger graduated cylinder, it's spread out because the surface area is larger, but still you measure at the bottom of the meniscus, and that's true for everything. So like this example here, this goes up 20, 1, 2, 3, 4, 5, and then I can see that the actual line is right here. The other line that you see on the other side is actually this where the water is pulled up against the backside, and you can see that. So we're actually going to measure right here where my mouse is. So this is going to be 20. So this is between 26 and 27 milliliters, but since it's right between the lines, it's going to be roughly 26.5 milliliters. So we would write down 26.5 milliliters. Now, the significance of me writing that is that, again, you have your counted numbers. You can actually measure those, and then you have the line that's in between here, and that's where you have to estimate that decimal place. And that's what we did here, is we estimated it at roughly 26.5. It's just like the ruler up here. You measure the values that you can actually count, and you estimate the last digit. The balance is the only thing that you don't do that with. The balance is just simply writing down the number that you measure. Now, you might be asking yourself, well, why are we learning this? Because we are in chemistry, we need to understand how to make these measurements. And so when it comes time for the test, there will be a section on the test where you have to physically measure the various units like we're seeing. So the ruler would be in centimeters, the balance would be in grams, so don't forget your units in this particular example. So that's important. So if you just write 2.013, okay, that's fine, but that's not right because you forgot your unit. Don't forget your unit. So mass is in grams, your ruler is going to be in centimeters, and then your graduated cylinder is going to be in milliliters. All right. So that's all I have for you in terms of measurements and the different tools. So thanks for listening, guys.